all. Good morning. We have all gathered here for a design thinking based discussion on how to organize the structural units of an embedded processor. So, as we all know, embedded processor is a core of any embedded application. There are a lot of wide variety of applications of these processor like healthcare, industry side, etc. So, but there is a challenge in organizing the structural units of an embedded processor while we are considering certain factors like speed, power, cost, and other constraints. So, you are here to discuss among yourself and get me a better solution in overcoming these challenges while designing an embedded processor. And we are going to apply design thinking concept. So we know that design thinking is a human-centric approach of problem solving by considering each and every needs of a user. Okay. So there are totally 5 stages in design thinking. So stage 1 is empathy, stage 2 define, stage 3 is ideate, stage 4 is prototype, and 5 is testing. So apply this concept and get me a good solution. So I'll give you 5 to 10 minutes. So hope you have completed your discussion. You can start providing the solution now.
So I'm going to be talking about the empathy part in the design thinking curriculum. So just like Ma'am said, we're going to be talking about the structural unit of the embedded processor. So in general, if we go deep into the processor, there are a lot of things to consider like power consumption, cost, and then the performance. So if you're taking a particular project, we have to know in detail about the processor so that we can go about it so that we'll get a better understanding about it. So in a embedded processor, we'll be having a lot of units like arithmetic logical units, control unit, register set, memory part, input output control, timing and counter, and all of this, those things. So if we know in detail only, we'll be able to use it for our project. So that like if we are learning about the embedded processor, we'll only know about the block diagrams of it. But if we get to know in detail about all of these things, it will be very easy for us to choose a particular processor because there's a lot of various types of processors. So that so in detail we'll see all of.
So I'm going to share about the defined part of this problem statement. So since the processor performance is required very much for the variable sensors, so the in what are the ways this processor should be embedded in the variable sensor should be must mandatory to follow. So at what combination and configuration plays a crucial role in designing and variable sensor. So in fact, what are the factors playing means peripheral controller and as well as power consumption and memory storage and as well as clock speed. So these are all the factors playing a crucial role while we are designing the embedded processor for an health sector, health monitor. And the next is we are designing a small wearable sensor which monitors the human's day-to-day uh, activities. It includes such as small ALUs as well as it can process the metabolism of the body, such as heart rate, pressure, and SpO2 level, sugar level, etc.
So when coming to the third stage of the design and this ideate part, in this stage we will put our brainstorming solutions and we will give a product as an optimal and then a cost efficient product. So when coming to the processors, processors are microcontrollers. We have various types of processors or microcontrollers are available in the market. Like various types means DSP processors or a system on chip processor and an ASIC processor. So most of the companies moved to this system on chip processor because it has the input of say arithmetic logic unit, general purpose input outputs, and it also has a control unit. So according to our application, we will choose if we are choosing a processor means I think we will move on to the system on chip processor. So if we take a scenario of if we are using the processor medical field means, so if we go for the real life application, ECG means it is used to measure the heart rate of the person. So in this we will handle the in milliseconds the processing signals. So we have to choose or design a processor according to that. So according to the processing speed. So in the processing speed section, if we will increase the processing speed, means it will radiate much amount of noise. So it will also a barrier for us. Then for if uh, if a particular person's heart rate is decreasing, means like pulse rate is decreasing, means we will do intimates someone else if we are doing the processor or connecting it with the mobile means. So we have to intimate that. So for that we have to introduce an interrupt control. So what this interrupt control do in this sense means beyond the operations that doing happening in the processor, it will generate a signal as an emergency signal, so that further operations will be stopped for some seconds, so that this priority interrupt is first handled. Then the operations which are to be normally doing on that processor will be done. So then coming to the memory constraint. So for this, the pulses will we get a second. So we have to handle that much of data in that memory. So for that we have to choose that memories sizes. So according to that, the processor will handle the loads without any stress or something. Then general purpose input output means. So for you have to choose according to the application you are using. Then much more information are there. So these are the main questions we have to see on that.
So I'm going to discuss about the prototype part. So in this, we using the basic processor unit instead of using the general purpose unit. So in the basic purpose processor unit needs it is which is it is see the applications and real life applications, and it will give the suitable for that. So it will improve the speed and it will consume the power efficiency. So it have the prototype. In this prototype we have the some like processors like arithmetic logic units, control units. Like arithmetic logic units process it to calculate, and the control unit it controls the processors and it improve the speeds. So the memory it have on chip, it have the flash memory and SRAM memory, and it also have the general purpose register. The general purpose register which is used to store the temporary memory, and it will improve the memory space, and it will give good processes.
So let us discuss about the testing criteria. As everyone said, embedded system plays the vital role in healthcare applications because it consumes the power direction using the arithmetic logic unit and interrupt it with the control units. It does not the embedded system does not make a design with an isolation. It interprets only the data what the users given. Then it can produce the control unit, and power consumption is mainly used for the embedded system.
So this, as per our discussion, so we have discussed about the major challenges faced while designing the embedded processor, and the factors which we have considered are speed, cost, and power. So thank you all.